All right, so welcome to this week's weekly workshop, second day of April. And this week we'll be talking more about CTF challenges, and we will dive into web challenges. So if you've been dragging through the discussions of networking challenges, this will be perhaps a welcome change. We will look at sort of an overview of web challenges and tools and approaches, and then we'll solve a couple of easy web challenges, and then next week we'll pick up on some more advanced similar challenges. First, so if you would like to participate and you don't have access to a Cyber Basics environment, I encourage you to pause here for a minute and set up or join the course that I've created, which will provide you a Cyber Basics 2018 environment. And that's Kali Linux VM and some other stuff. And you can do these web challenges from the Kali Linux VM. And then there's a practice CTF. So if you haven't been involved in the practice CTF yet, please go to backer.io/practicectf, and you can register and start playing right away. So weekly workshop every Tuesday at 1 p.m. or not every Tuesday, most Tuesdays at 1 p.m. unless there's some conflicting event or travel. We record them. They're all hanging out on virginiacyberrange.org, and that's how most people seem to consume them, as they watch them after the fact. Good way to use this particular CTF series is to sort of select portions of it and play it in the classroom with your students or with your cybersecurity club, and then have them solve some challenges. And the benefit of using these videos is they show how to solve many of the challenges that are on the Practice CTF site, or you can just watch me do it and then do it yourself for your students. Either one doesn't matter. And so a couple quick news stories. I'll keep this short so we can move on to the web stuff and finish up maybe a few minutes early. Hackers steal $19 million from BitThumb cryptocurrency exchange. This is a recurring theme, right? This happens every, few weeks. Large sums of money are stolen from various cryptocurrency exchanges. The thing I found interesting about this particular story is that this same exchange was hacked for $31 million in 2018 and for $1 million in 2017. So that makes you wonder how people could possibly still use them. But I guess people do, because they just had $19 million stolen. Seems like it was an inside job, is the take that the investigation, that's the road the investigation is going down right now. So somebody within the organization stole the money. And maybe not surprising, BitThumb recently halved its workforce. So this is before this $19 million hack. They cut their workforce in half. They had over 300 people working at the exchange, and they halved it to 150. And that's really largely due to the sort of long-term drought in cryptocurrency prices. If you just think of Bitcoin, for example, remember a little over a year ago, it was, in late 2017, the price of Bitcoin was, in the $20,000 range, and now it's been in the $3,500 to $4,000 range for the last many, many months. And so, so these companies that whose business is involved in cryptocurrency, they just don't have, the money isn't flowing in like it used to be. So this is one organization that had to reduce their size of their workforce. Second major bullet here, Commando VM, right? So this is Kali Linux for Windows users, essentially, is what it is. Commando VM is a penetration testing suite similar to Kali Linux. Although with Kali Linux, you download and you can download the operating system. Kali Linux comes with the whole underlying OS, as well as all the tools layered on top of it, and you can install that in a virtual machine, or you can install it on hardware. Most people use it as a virtual machine. Commando VM is a little bit different because it's meant to sit on top of Windows, and Windows is not a free open source piece of software like Linux is. So if you're going to use Commando VM, what you have to do is you download the installation package, and then you install that on an existing Windows virtual machine. You could install it on an existing Windows hardware install, like on your laptop or on your desktop at work, but that's not recommended, because in order, sort of similar to Kali Linux, some of the things that Commando VM does to make it a more robust penetration testing VM is that it does things like it turns off the firewall, and it makes the primary user the administrator. So everything you're doing is with administrative access, and turns off the AV because there's overhead involved in antivirus, and if you're using a VM for penetration testing, you probably don't want the antivirus to be on, because you may be using malware as part of your penetration tests, and if your AV quarantines it or deletes it or whatever, then that kind of screws you up. So the creators of Commando VM, and I should have mentioned that earlier, the creators are FireEye and Mandiant. So FireEye/Mandiant is two companies that merged about 3 or 4 years ago, and they're a pretty powerful force. So FireEye makes next generation firewalls, application layer firewalls. They've done that for a long time. They were one of the first companies that did this thing where they would, if they saw unrecognized malware, they would spin up a VM, and they would, the firewall itself would spin up a virtual machine, and then do this analysis of the software in the virtual machine. So anyway, pretty cool technology that's pretty widely used these days, but FireEye was one of the first. So that's the company, FireEye/Mandiant. They provide this Commando VM package, and so basically you have to have an extra Windows license in order to use it, because again, you want to use it as a virtual machine. You don't want to use it as your everyday operating system. So there is a cost associated. You don't have to pay for the Commando VM part of it, but you have to be willing to pay for an extra Windows license. Of course, if you're in a place where you have Windows site-wide licenses, then that's probably not as much of an issue. But anyway, last major bullet here. Researchers tricked Tesla Autopilot. So this is a story that came out within the last couple of days, and basically what these folks were able to do is they were able to put. So if you look at the picture on the right side, they're basically able to put some reflective dots on the road, 3 dots, and those 3 dots were sufficient to make a self-driving car, particularly in this case a Tesla, think that it's time to switch lanes, and basically they're switching lanes into oncoming traffic, right? So this is a attack on self-driving vehicles, and so you have to think a little bit more about what the threat model is, right? You're not just worried about somebody hacking into the vehicle, but if somebody is able to place something physically on the road that causes your sensors to do the wrong thing, then that is certainly a threat that needs to be considered. So pretty clever technique, I thought. Okay, so this next story is about this notion of responsible disclosure. So this is a news story from earlier today on the Hacker News. It's about unpatched 0 days in Microsoft Edge and Internet Explorer browsers. So there's I think he's a student, 20-year-old student who found some vulnerabilities in Edge and Internet Explorer related to cross-site scripting attacks, and the story is basically that he informed Microsoft of these vulnerabilities 10 months ago, and that Microsoft hasn't done anything to mitigate. And so now he is basically announcing these to the world under this notion of responsible disclosure. And this, I think, is a good discussion to have with students, because there is an ethics issue here, both from the perspective of the security researcher who is doing the responsible disclosure, and from the perspective of the company who's being informed of this vulnerability. So what is responsible disclosure? Responsible disclosure is this notion that if a security researcher finds a vulnerability in a piece of software, what they should not do is they should not immediately announce it to the world. What they should do is they should inform the company and give the company some amount of time to mitigate the vulnerability or to patch the vulnerability. Usually that amount of time ranges from 3 months to maybe up to 6 months. At least 3 months, I think, is sort of the the penetration testers standard thing. And if the company doesn't patch the vulnerability or mitigate the vulnerability, then at that point the security researcher has done the responsible thing. They've notified the company that creates the software, and now they're sort of free to announce the vulnerability to the world. And people are on either side of this debate. One side says, well, that person should not release that vulnerability, because then people will quickly create exploits tied to the vulnerability, and then you'll start seeing people actually exploit the vulnerability in the wild. And so now you're exposing people that you shouldn't be exposed. The other side of the debate is, well, if some security researcher discovered this vulnerability, then it's very likely that some malicious person has discovered it also already, and that could be some hacker who wants to hack into systems and steal people's money or identity, or it could be a nation state who wants to hack into other government entities for the purpose of espionage or whatever. And so because there's a vulnerability, people should be informed, so that even if the software maker doesn't create a patch, people who use that particular software can put in place their own mitigations. So they may be able to reconfigure their firewall to account for this now known vulnerability, or they might be able to, they'll at least know the vulnerability is there, and they can perhaps decide not to use the software. So, so this is a good sort of ethical debate or discussion that you can have with students in the classroom. This whole notion of responsible disclosure, and first of all, what it means, and then what kind of the ethical implications are, and what are the different sides of the story. Okay, that's it for news today. So this week we're back to solving CTF challenges, and we're going to look at some web challenges, and we will look at more web challenges next week. And yeah, so if you haven't paused and got stuff ready to roll, then you can pause now and use this slide to get the practice CTF up and get a Cyber Basics environment up if you don't have one available to you. Okay. And let me switch to my other slides. Okay, so we've spent several weeks talking about different kinds of CTF challenges. I think we've covered cryptography challenges in pretty good depth, and we've talked about, what else have we talked about? We've talked about networking challenges. Today and next week, we're going to talk about web challenges, and we still have yet to spend a couple of weeks talking about reverse engineering challenges, and we'll probably wrap up talking about reconnaissance challenges. Those are sort of the catch-all. If a challenge type doesn't fit into some other bucket, then it might turn into a reconnaissance challenge. All right, so so there are of course different difficulty levels in any type of, or any category of CTF challenges. So today we're going to drill in on some of the easier web challenges that you might see. And in general, for the easier challenges, so for the low point value challenges, you're generally going to rely on your basic understanding of HTML and how websites work. So an understanding of HTTP, the interaction between a web browser and a web server, is an HTTP interaction, a request for resources, and then a serving of resources by the server, and then an understanding of HTML. And so that gets back to sort of the historical way that the internet worked, and I'll talk about that some on the next slide or two. Generally, it's a little bit different today. Web pages are a lot more dynamic, but in the early days, people hard-coded HTML by hand, and pages were a lot more static. And it's helpful to understand, what HTML is, what markup languages are, and then when you see a dynamically generated web page, you have a much better understanding of what's going on. So easy challenges rely on students' basic understanding of HTML and how websites work, and I guess I'll add to that the HTTP protocol. And so as you're solving these challenges, approaches are going to be things like viewing the page source, right? If you can look at the HTML that underlines a web page, then you can often find some hint as to what the flag is. You might want to open the developer panel, right? So on Chrome, for example, you hit F12 and you get this developer panel that comes up, and that lets you examine the HTML code as well as any scripts or other things going on the web page. You might want to examine the network traffic, so we'll probably get to that today. We will look, we will record a web interaction using Wireshark, and we'll see the request and the response. I think we might have done that back when we were doing the networking challenge discussion. You might curl the web page. So curl is a command line tool that you can use to grab a web page from a web server. And there are some benefits to using curl instead of using a browser if you want to make sure that you capture each step of the interaction. Sometimes you'll get things like web redirects where you'll go to a particular page and then that page will immediately redirect you to another page. And when that happens, it's hard to catch that in your browser. You just never see that whole redirect, and you're never able to examine the HTML underneath the original page that you went to. But if you curl it, then you're going to see that access of the original page, and then you'll see the redirect, and you'll see what happens during the whole exchange. And that's because curl is going to dump everything to your to standard out, right? So you're using a terminal window to use curl. Again, it's a command line tool. So everything that is returned gets dumped into your terminal window. Look for the robots.txt. We'll talk about robots.txt in a challenge that we'll solve in a few minutes. Directory traversal attacks. This is sort of an interesting thing. You don't see this very often these days, but you do see it once in a while. This case where you might be able to say something like example.com, and then you might be able to say .. and then look for some file like maybe password file, for example. And so, some early web servers, so first of all, when a web server returns information to a client, to a browser, what they're doing is they're grabbing, in the case of sort of the simple HTTP interactions, they're grabbing an HTML file out of the file system and they're just returning it to the client. And so some early web servers didn't do a good job of isolating where the content could come from that was returned to the client. And so you could go to your web browser in the URL bar and you could type in HTTP www.whatever.com/ and then you could sort of go up and down the file system using standard directory traversal notation. And obviously that's a flaw, and that's something that you generally don't want in your web server to do. But there are cases where you might want that sort of behavior, and it's something that in modern web browsers, that's a configuration that you turn on and off. It's obviously in general off in most cases, but once in a while a web server will turn it on for some reason, and so that's something that you might see in a CTF challenge. Okay, so just very quick history lesson. You've probably seen this before if you've seen me talk about networking in any of these weekly workshops. So there's this early model of the World Wide Web where you have a browser, and that's you sitting in your office with your laptop browsing to web pages, and then you have a web server, and that is the server system. So that could be whoever it is, might be CNN.com, might be Wired.com, it might be vt.edu. And in the old days of the web, you had the web pages were HTML files. And so here's an example of an HTML document. You have it starts with, it's this markup language, so it starts with the HTML tag, and then the next is the head tag, and then between the head tag and the close head tag, there's stuff in the header of the document, of the HTML document, and that could be the title of the document. You might also see some style information in there, so we'll take a look at some of that here in a minute. Style is meaning, what should a paragraph, what should the default format of paragraph look like? What should be the background color of the page, et cetera, et cetera. And then you have the body of the document, so that has a body tag and a close body tag starting and ending it. And then everything here in the middle is, this is the body of the page. So you might have something like, H1 for large headline, and then you might have at the top of the page, title, and then you might have a close H1, and then you might have a paragraph tag, then a closed paragraph tag, and then this is going to be some body text. Then of course you're going to have image tags interspersed through all this, and all those have a specific format. But these are all static. This is what a static web page looks like. That means it's saved on the file server as essentially a text file, and that's what is returned to a client when a request is made of the web server. So now things are different. And this isn't true for all websites, but it's true for most of them these days. So now what happens is when you connect to a web server from your browser, there's the same GET request, right? So up here we had a GET request, and then on the web server side, the web server gets this HTML file out of the file system, and then it returns the HTML file back to the web browser. And then the web browser is just going to render that web page in the browser window, and it's going to go back and, so there's like some figures in here, right? So the figures is going to go back to the server and ask for that file, and then when the server returns it, it's going to render that in the page. So pretty straightforward, basic early HTML interaction. These days you see a lot more of this. You have the GET request, and in this case, the GET request is getting a form, and so here's Google's search form, right? So the form is returned to the client, and then on the client side, you're going to type some bit of data into the form, and then you have this post HTTP request, and the post is going to post data to the database, and you're going to get this response, and you're going to get some data back from a database. You're also going to get a template for the web page, but this is not the web page itself. It's simply a template. And now the actual content of the web page is going to be generated dynamically using things like PHP, which is a interaction live interaction between web clients and web servers, and we'll see more PHP next week. You might have Windows Active Server pages. You might have JavaScript and other kinds of scripting languages, but these are all things that provide this like real-time live interaction between web browsers and web servers. And in these cases, the client is typing things into a web browser, and then there's some action taken on behalf of that client at the server side. And anytime you can get the server to take action on your behalf, that's more than just grabbing a file out of the file system and throwing it back to you. Anytime you can get the system to look up something in a database or execute a command or whatever, there's always this potential for some level of abuse. And so the more advanced CTF challenges related to the web are generally things that are things that could be abused on real websites. And of course, the idea is to teach students these potentially malicious things that could happen, so that when they're creating websites later in life, they can avoid the pitfalls that some people fall into when they do this. It's also important to understand the HTTP protocol and how it works. So we'll take a look at this in a second here too. So here a browser is looking for a URL, and the URL is of the form host, so that could be vt.edu, for example, and then a port. So if the port is left out, so I could say :80, but that would be redundant. The default port for a web server is port 80, so you don't have to put that in if it's port 80. And then you have the slash path to the file. So that could be index.html. Again, for most web servers, index.html is the assumed web page to be returned if no web page title is specified. But you might see this whole a URL that has this entire format, http://host:/port/ and then path to a file with multiple slashes indicating where in the file system to find the file that you're looking for. And so then what the browser does is it sends a GET request, an HTTP GET request, and it includes the URL. It tells the server the HTTP version it's using. It has the host, and then it has some header fields. And we'll look at some of those header fields in a minute. And then the server is going to do what it's going to do. It's often just, again, in the old school model, it's just grabbing a file off a file system, and then it returns. If it is able to find the file that it's looking for, it returns HTTP 1.1. So it responds to the client that says, yes, I understand HTTP 1.1, and I agree that that's a format that we can use. And then if the file exists, it's going to return a 200 OK message. It might return a 404 message if the file is not found on the server. And then there are other different kinds of error messages related to scripting errors or whatever. But the standard return response that you're going to get, 9 times out of 10 is you're going to get this 200 OK response, and then the server is going to return the file that you requested. Okay, so let's do this real quick just to remind people of this. And again, if you've done this before and you know what this looks like, then you can skip ahead 5 minutes or so. But what I'm going to do is I'm going to go to my Cyber Basics environment, and I'm going to open up Wireshark, and I'm going to open it up as a root user so I can capture live traffic. I'm going to set a display filter to HTTP. I'm going to browse to a web page, and this is the web page I'm going to go to, secretsquirrel.com. And then I'm going to stop the capture, and I'm going to follow the TCP stream of that web interaction, and we can look at the HTTP request and response. And so let's switch to, if you notice I already have this queued up, so I'm going to maximize my browser window. And then I'm going to click the join button. And I'm going to log in. I'm impressed every time I do this and how well this works. Terminal window. Okay, so you can start Wireshark by, I guess here's the, you can go to Internet, Wireshark. This is Wireshark version 2 point something, 2.4.5. There's just Wireshark 3 released within the last couple of days, which I, oh, and I'm not running this as root, so I don't want to do this. Yeah, so Wireshark 3 was just released. I played with it a little bit this morning, didn't see any difference, but I'm sure there's something better about it. So I'm going to say, yeah, so instead of, I want to make sure that I start Wireshark as a root. Why am I doing that? Well, I'm doing that because I want to capture live traffic off the network interface. And unless I'm running Wireshark as root, it won't let me do that. So I'm going to go to the command line, and I'm going to type in sudo. Remember, sudo lets me run things as a administrative user. And then I will type in Wireshark. I'll put an ampersand, runs in the background, and here I am running Wireshark. And whenever you do that, you're going to get this error that says, you're running Wireshark as a super user. You maybe should not do that, but we're going to do it anyway. Okay, the next thing I'm going to do is I'm going to capture some traffic. Let's see if I can make this window not, there we go. I'm going to capture traffic on ETH0. So if you look at this, you know, this sort of homepage that comes up, you can see that the ETH0 interface has ongoing network traffic, and then there's any. So any will capture traffic on any network interface, and then there's no activity on these other interfaces, loopback and etc. So I'm just going to capture ETH0 traffic, and then I'm going to curl HTTP. Whoops. www.secretsquirrel.com. Okay. Now I'm going to stop my capture. So I'm going to go back over to my terminal window, and you'll notice that when I did this curl stands for, the URL part stands for URL. I'm not sure what the C stands for. I could probably say man curl and find out. Transfer a URL. Curl is a tool used. I don't know what the C stands for. Anyway, capture URL maybe, I don't know. Anyway, so what curl does is the command that you give it, so like any other Linux command line tool, it has all kinds of switches that you can use to make it do funky stuff. In this case, all I'm doing is I'm grabbing a web page, and so I'm going to secretsquirrel.com, and there's an HTML or an HTTP interaction that happens, and we're going to look at that in Wireshark here in a minute. But curl doesn't care about that. It just it requests the web page. The HTTP interaction happens, and whatever is returned by the server is what gets dumped out to the command line here, so or to the terminal window. So here's my HTML tag that starts the file, and the next bit of this is formatting info, right? So here's where the header starts, and so this thing is worth mentioning. Here, there's a open tag and then an exclamation and 2 dashes, and then there is 2 dashes and a close, you know, whatever it is, greater than sign, less than sign. That is a comment in HTML. And so you'll often see, if you're looking for flags in an HTML file, you'll often see the flag in a comment. Not always, but often. Okay, so so in the you know, so you have HTML, then you have a comment, and now we have the header of the HTML file, and inside the header is a bunch of stuff related to formatting. So this says, you know, the contents item, the background color of that portion of the page is going to be FFFFFFF, which is white. You know, here's more. You know, it's formatting colors, specifying padding around text boxes, you know, all that kind of stuff. And so there's a bunch of that going on. And then, so that was the style section. So there's a style tag opening it, and this is the close style tag, and that's all still in the header. So that never gets rendered on the web page. That just tells the browser, when these elements come in for you to render, here's the formatting. That's not this particular page has a whole bunch of that stuff. That's certainly not the case. In early web pages, you'd basically have something that specified the background color of the page, maybe something that specifies the font color, and then there wouldn't be much in the header section. Then here's the body of the web page, and again, this is the stuff that gets rendered. So this is these are divisions. So here's the thing that says table of contents, and then here's the different portions of the table of contents. And then at the bottom here, you have a close of the, you have these nested divisions, and then at the end you have a closed body tag and the closed HTML tag. So that's the whole HTML file that got passed, and this is a text file sitting on the web server. And then here's the packet capture of that. I'm going to go up here into the URL or into the filter bar, type in HTTP. It's going to filter out everything except for the HTTP traffic. This is a very simple interaction, right? There's a request for a page, and there's a response from the server. And I'm going to go to follow TCP stream. And now what I see at the top, here's the request. And again, this is the HTTP interaction. Get, and then it gives the resource, so http:// server name, www.secretsquirrel.com, and it doesn't need to put the :80 because the port 80 is assumed. It doesn't need to put the /index.html because if I don't put that, then that's what's going to get returned. So this is a very simple request, and then we're using, the browser is using HTTP version 1.1. And the host I'm contacting, again, is www.secretsquirrel.com. User agent, so user agent string, this tells the server what my browser is. And the reason I do that is because sometimes the server will tailor content based on the browser. So you might see something different in Firefox than you see in Chrome, for example. So here's my user agent string, and it says I'm using curl version 7.64. I'm going to accept any type of content, and there's this keep alive that just says keep the connection alive as long as you can. And then here's the response. Here's the 200 OK I mentioned. That means yes, I have this page, and I'm going to return it to you. The server is an Apache server. The page was last modified on 1st of January 2018. There's some other stuff in here that I'm not going to talk about right now, but it's all relevant to how the response is formatted. And then here's the response, right? And this is exactly what we saw if you look over here in the terminal window. If we go up to the very top of the page, here's the HTML, then you have this www.w3.org, yada, yada, yada. You have the start of a comment, the close of a comment, you have the head section, same stuff. That's what you see in the packet that was returned from the web server. And what the browser would do is just take all this and render it appropriately in the browser. Okay, so it's helpful to understand that interaction when you're solving web challenges or when you're troubleshooting web pages. Okay, so now what I'm going to do is I'm going to open up my browser. I'm in my Cyber Basics 2018 environment, and I'm going to go to backyard.io/practice-CTF. We're going to log in here, take a look at a couple of CTF challenges. There's me right there. Okay, and now I'm in. So here's my CTF challenges. Let me go to the web challenge. So, as usual, we have a variety of challenges of varying point levels. And so we're going to start with a simple one called Agent 000. So this web challenge says, Secret Squirrel has a secret message on his homepage at www.secretsquirrel.com. Okay, on his homepage. So I'm going to copy that, and I'm going to go to Okay, so here's the home page. And this home page is this, right? So I did this curl for www.secretscroll.com. What I got back is index.html, and that is generally referred to as the home page, right? That's the standard page that's returned if I don't specify a different page. So this home page has an image, it has this table of contents section, and there's not much to it, right? So here I can, looks like there's some buttons here, so I can get to other pages, but the challenge says that there's a hidden message on the home page. So I'm going to assume for now that that hidden message is on this home page. And so I mentioned you could bring up the developer tab. Let's see if I can get the developer tab to work on my VM. Oh, there it is, the bottom. I wonder if I can attach it to the side instead of the bottom. Side of browser window. Yeah, there we go. So this is my developer tab, and the developer tab again has things that a developer might use to troubleshoot the page. And what it also has is, let me try to make this top portion a little bit, there we go. What it also has on this first tab is it has the HTML, and then these other tabs have other stuff in them. So this is scripting, info, one of these will have cookies on it, one of them has style sheet information, etc. So if you spend a little time in the developer tab, you get a feel for these different things. But I'm going to start in the HTML window. And so here I see, as I point to different areas in the on the page itself, I see the corresponding area over on the right side in the developer window. Same, if I point to stuff over here, I see the corresponding thing in the on the page itself. So I'm looking for a secret message, and this particular one, there's a couple of different ways to find it. This one kind of jumps out at you a little bit. There's a comment in here that makes you think that you have to go to something called hidden.html. We could try that out, but I'll tell you that that is a red flag, or a red herring, not a red flag. Yeah, so there is no hidden.html. That's just it's a bit of a red herring. So I'm going to go back. And as I expand out the components of this web page, what you don't see on the web page, but what you see in the HTML is you see a paragraph that says, "Could this be the secret message?" And I'd be willing to bet that that could be the secret message. And there's probably not an easy, let's see if that works. Control C. I'm gonna try to paste it in my Control V. Oh, there we go. Got more than I wanted though. Okay, so that's the answer. Now, I'm going to go back to the page here, and let's look at the page, and you might say to yourself, why is that a paragraph in the HTML, and it doesn't look like it's commented out, but it doesn't show up on the page? And the reason for that is that it's white text on a white background. So that text is actually down here. And so if you highlight the text, you can see it. It says, "Could this be the secret message?" So that's a different way to get this particular flag. You don't see it when you're just looking at the page because it's, again, white text on a white background. Okay, let's go up a level here. Worth a few more points. It says, "What is secret trying to hide?" And the name of the challenge is robots.txt. And if you recall, the name of the challenge is often a hint. So we know that secret is trying to hide something, and then there's the name of the thing is robots.txt. And so if you don't know what that means, you might Google robots.txt. And you get robotstext.org. Okay, there's lots of information about robots.txt. So this is the web robots page, and it says web robots, also known as web wanderers, crawlers, spiders, are programs that travel the web automatically. Search engines such as Google use them to index the web content. Spammers use them to scan for email addresses. They may have many other uses. Here's a page about robots.txt. And this will tell you that website owners use a robots.txt file to give instructions about their website to web robots. This is called the robots exclusion protocol. And so basically, the robots.txt file sits in the root folder of the the root directory of the web server, the root directory of pages that it's going to serve up. So alongside of index.html, there's going to be robots.txt. And so what web crawlers are supposed to do is they're supposed to read the robots.txt file, and the robots.txt file tells the web crawler pages that it should not index. And pages on that website that it should not index. And you can imagine why an organization might have portions of their website that they don't want web crawlers to index, right? They might have sort of an employees only section, stuff that they only want their own employees to be able to get access to. And they don't want it to show up in Google if somebody searches for the name of one of their employees, for example. I mean, there may be lots of other reasons why you would do that, so web crawlers are not supposed to index things that are specified in the robots.txt file. And now the flip side of that is the robots.txt file has to be world readable in order for web crawlers to be able to read it. And so if you're a malicious person who's doing a penetration test against an organization, you might look at their robots.txt file to see what portions of their website they don't want sort of the average run-of-the-mill person to be browsing, and then you start browsing those portions of the website. You're not prevented from getting to them. It's just that a web crawler won't index those sites on a search engine. So what I'm going to do then is I'm going to go to my secret squirrel, back to my secretsquirrel.com, but this time I'm going to append onto the end here /robots.txt. Oops. And this is what one of these files looks like. And basically, you have this disallow tag. And so maybe I'll click over here. Robot wants to visit a website URL. Before it does, it first checks robots.txt. Means that so if you put disallow and then just a slash, that means don't index anything, because you're specifying the root of the file system and anything after that. But what you normally see is the name of a directory there. You'll see slash and then a directory name. And so if I go back to my secret squirrel example, the robots.txt basically says you can index everything except stay out of the folder that is /secrets. Okay, so then the next step would be to see what secret squirrel is hiding there. So I'm going to type in secrets and then slash, and okay, and then here is what is in that folder. It's simply a text file, and this is the flag, right? What's secret trying to hide? Trying to hide this flag. So I'm going to copy that. And there we are. Okay, one more quick challenge we're gonna solve here. And then next week we'll get to some more sophisticated web challenges. So this one's called career change, and it says secret. There's lots of secret squirrel going on here. Huh? Secret is considering a new career, but is keeping it secret. There is a flag double hidden somewhere at http://secretsquirrel.com/more-secrets. So let me go there. Okay, this is on Secret Squirrel website. So there's something hidden here, and again, it's one of these things where you don't see anything that's amiss. So what could that be? I'm going to do some highlighting here. Highlighting doesn't show me anything. And so maybe I want to look at the page source. So how do I look at the page source? Well, I can do my developer tab thing. And that, I'm not sure what I did there, but something that I didn't want to do. Let's do this a different way. Let's, here's what I'm going to do. I'm going to copy this, Control C. I'm going to curl this. It's one approach, not the only approach. You could look at this in Wireshark. You could use a web. You could use a proxy, which we'll take a look at in maybe next week. But I'm going to curl, and then I'm going to paste. So I'm curling secretsquirrel.com/more-secrets. What I get here is a bunch of stuff, and here it is, right? So this is familiar. There's the header section. And we see a bunch of various formatting info. Don't see anything particularly interesting here. Here's the menu. And here's something that could be promising. Here's a comment that's commented out this hidden.html menu option. And I tried that just a minute ago. I tried to browse the hidden.html and there's nothing there. It was kind of red herring, so I'm not going to do that again. But you know, that's the kind of thing I would be looking for, something in comments. And here's something else in comments. And what we see in comments is a reference to a figure, album cover.png. Okay, so that's an image that would show up on this page, except it's commented out. Okay, so how do we get to it then? Well, we can go back to our browser and we can go to secretsquirrel.com and we want to go to the More Secrets page. More Secrets. Okay, that's this. And then we don't want to look at the index.html. We want to look at that. We want to look at this. Album cover.png. So I'm going to copy that. I'm going to go here. I'm going to paste. And we get what looks like an album cover, right? So this is a Secret Squirrel, Essential Squirrel Beats Volume 1. And something about this is supposed to give us the flag, right? So if we go back to the hint, what was the hint? Oh, I went to the, is this my thing? No, lost my thing. Okay, this is my thing, right? I lost my CPF. Let's go back to the challenges. Okay, career change, back to where I was. Okay, considering a new career, keeping it secret, there's a flag double hidden somewhere at this place. Okay, so double hidden, right? So there was a comment in the HTML that pointed you to this image, and so the flag must be hidden again in this image somewhere. A couple of different ways you could hide things here. You could use steganography, where you're embedding bits into the image to, get around somebody who's trying to discover your secret communications. This is a 35-point challenge, so we're not expecting to see anything quite that advanced. But if you notice here around the edge of the image, there is something that looks like Morse code, right? Dash, dash, dot, dot, dash, dot, 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 dash, dash, dot, et cetera, et cetera, et cetera. Dots and dashes around the edge of the image. And so what I would do next is I would find a web page that would translator, Morse code translator. Yeah, so I would find a page that would translate my Morse code. So, whoops. So if I was here and I dash dash dot dot dash dot. So here I could say dash dash dot dot dash dot and translate, and I get the first portion of it, right? So if I were to keep going, I would get more characters in this message, and then that presumably would be my flag, I'm pretty certain. Okay, so I'm going to stop there. So those are sort of entry-level web challenges and solutions from the practice CTF. And again, I would encourage your students to hack on some of these, and then give them some time to work on one, and then show them how you'd approach it. Give them some hints maybe, and then show them how to solve it. That's a good way to get students started on CTF challenges. Okay, so I'll stop there, and we will talk a little bit more next week about some more advanced web challenges. So thanks.